Okay, what's next under forces? 2.2, action and reaction. Okay, so according to Newton's third law, if we have the action of a force always is accompanied by an equal and opposite reaction. Okay, so object 1, object 2, right? So there's that force is accompanied by that force. So if this force applies a force onto that body, there is an equal and opposite reactive force onto that body. Now, why do we bring this out? Because if we're analyzing the forces on this object, say, you must not mistake or confuse which of these forces is acting on the body. Remember, if we draw a free body diagram, which we'll get to at some point, do not draw the forces that are exerted by the body, not the forces exerted by the body, which would be that one there. You need to draw the forces that are exerted on the body, okay, which would be the force of that object onto that object. Okay, make sure that you're clear about that. Okay, the next thing that we want to cover in this video is the idea of concurrent forces. What is a concurrent force? It's just forces that act at a point or their lines of action intersect at a point. Okay, so here we go. So you've got two forces, F1 and F2. They are both being applied at point A, which means they are concurrent. Okay, they are being applied at the same point, or they are being applied over there at that point and that point, but their lines of action coincide at a point. Okay, remember, principle of transmissibility. Because we're dealing with a rigid body, if a force is applied there, we can apply that force anywhere along its line of action to have the same net external effect. So these two situations are equivalent externally. Okay, so what do you do now? So if you've got these two forces and they're concurrent at a point, then we can use the parallelogram law of vector addition to get a resultant. Okay, use the parallelogram law and get your resultant vector. Same here. Extend the line of action until it reaches the same point, and then you can use the parallelogram law. You can also use the triangle rule. Okay, so say now we have F1 there. We take F2, we take the tail of F2 and put it on the head of F1, and we can get the resultant force R acting on this object. So guys, basically what we're saying here is you've got F1 and F2 acting on this rigid body. It's the same as just simply saying R, this resultant force. It has the same external effect on the body. Okay. Now, how should you not add head to tail? Well, you should not do it this way. Okay, so you've got that F2, and we apply the head over here at F2, at A, and the tail of F1. So you are using the head to tail method, and you are getting R, and this R, by the way, this vector sum R is in the same direction and has the same magnitude as this one, but you can see that its line of action is wrong. The line of action should be there, but its line of action is there. So be careful when you are applying. Don't put the head where the tail should be, is basically what we're saying here. Okay, keep the tail where the tail should be, and then apply it in this way. Okay. Oh, here's an example of concurrent force. Here's a real-life example. As you can see, you've got three forces in this case. Whoops. they're all concurrent at a point. Okay.